right, so a couple students had asked me to solve a few more mixture problems, and I'm going to do just that. My PowerPoint wasn't working, so we're going with PDF for old school style. So at least then I can mark these up a little bit better. So our first example is a party mix is made by adding nuts, so mixing them together, i.e. a party mix, adding nuts that sell for $2.50 per kilogram to Chex that sells for $1 per kilogram. How much of each should be added to obtain 30 kilograms of a mix that will sell for $1.70 per kilogram? When it comes to these mixture problems, we've always got to make a table. And it's not the most beautiful table in the world, but I try. So that last row, the bottom row, is going to be our final. Like I know in the end, I want 30 kilograms of mix that costs $1.70, right? So this first row is going to be what we're mixing together. That's going to be like our nuts and our Chex Mix. So like what we're mixing. And then the second column is going to be the cost of the individual kilograms. So for example, I know the cost for nuts is $2.50. So my total cost, if I bought like one thing of nuts, would be $2.50. But if I bought 2 kilograms of nuts, it'd be $5. So we have to multiply this across. So I'm going to have 2.5 in. I do the same thing for Chex, which sells for $1. 1 times C is just going to give me C. You can put a 1 in front, but again, you don't have to, and typically in math we wouldn't. So if I know I've putting in $2.50 for every kilogram of nuts and and it costs $1 for every kilogram of Chex, then my final cost has to be the same. And I know it costs $1.70, so I'm going to multiply across again. That gives me 51. These first 2 columns, these gives us our equations that we can solve. I have N plus C is 30 kilograms, and 2.5 N plus C is 51. And I didn't need to write kilograms per se. I take that off, right? This is the system we're going to solve, but know that our final answer is going to be in kilograms. It's how many nuts we're going to need to mix, and how many kilograms of Chex we're going to need to mix. I decided to solve this one by elimination because I noticed that the leading coefficients in front of our C's were the same. But in order to solve this by elimination, I need one of them to be negative. So I went ahead and multiplied this top row by -1. And then I'm just going to like rewrite my equation. So now I have negative n minus c is -30, and I add that to 2.5 n plus c is 51. That gives me 1.5 n is 21. So if I divide both sides by 1.5, I get n is 14. That's my CAD. So I need 14 kilograms of nuts. Well, I know based on this first equation up here that n, maybe not highlighter, that n plus c, hi Bobbie, we all hear you, that n plus c is 30. Well, now I know that n is 14, so I'm going to substitute that in. 14, hi Bobbie, 14 plus c is 30. I subtract 14 from both sides. So I get that C is 16. Yeah, so there's 16 kilograms of Chex Mix and 14 kilograms of nuts. It's a very exciting problem, isn't it, Kitty? You guys. So for example 2, I want to know how many gallons of 25% alcohol and 30% alcohol must be mixed to obtain 20 gallons of 32% alcohol. So again, I'm going to need a table, something generally table-shaped. And that final row is going to be where I put my final amounts. So I know that I'm going to have some gallons of our solution and our percent alcohol. And that's going to give me my gallons of pure alcohol. And I shortened it because My handwriting's bad, and that's a long word. So I know that at the end, I want 20 gallons of 32% alcohol. Let's write that as a decimal. And I've got to add some amount of 25% alcohol and some amount of 35% alcohol in order to do this. What are those amounts? Well, this is the perfect time for a variable. I'm just going to use X and Y, unlike with the Chex Mix and the nuts. There were no variables really jumping out at me. So now I have to multiply across, because if I take my gallons of solution times my percent alcohol, that's going to give me the gallons of pure alcohol. So X times 0.25 is 0.25X, Y times 0.35 is 0.35Y, and 20 times 0.32 is 6.4. Again, this first column and my last column are my equations. I have X plus Y is 20, and 0.25X plus 0.35Y is 6.4. I decided to solve this one using substitution, so I need to isolate a variable. I decided to go ahead and isolate X. So I did that by subtracting Y from both sides. That gives me a brand new equation. I've got X equals 20 minus Y. And I can go ahead and substitute this in for X right here. So I have 0.25 times 20 minus Y plus 0.35Y is 6.4. I'm going to go ahead and distribute. 0.25 times 20 is 5. 0.25 times Y is a negative Y is a negative 0.25Y. And I'm going to add that to 0.35Y. Let's go ahead and combine like terms. So I have a positive 0.1Y equals 6.4. Subtract 5 from both sides. 0.1Y is 1.4. That means Y is going to equal, if I divide by 0.1, my cat really wants to play, y'all. Hi, honey. I can take that toy. Thank you. Is 14. Now, since I know that X plus Y is 20, I plug in 14, bless you, for Y. So I'm going to get X plus 14 is 20. So X is, after I subtract 14, of course, is 6. So I need 6 gallons of the 0.25% alcohol, because that's what X represented, and 14 gallons of the 0.35 of the, well, not point, but 35% alcohol. This would be our final answer. This one's more similar to what we've seen. I know a lot of these problems are chemistry problems, but they don't always have to be. Last example, what's more fun than fruit punch? So a fruit punch is made by mixing juices. A drink with 50% juice is to be mixed with a drink that's 30% juice to obtain 200 liters, this is a lot of juice, of 45% fruit punch. How much of each drink should be used? Again, table. So this is going to be the liters of juice and the percent pure juice. I feel like all juice should be 100% juice, but you know, apparently it's not. And that's going to give me the liters of pure juice. So maybe I should call it like juice solution. I know, Bobbie, I will be done with this video soon. So juice solution. So I have some juice, my final, what I want, right? That's our last column. That's what I would do first, is I want 200 liters of 0.45% juice. I know I have some 50% juice that I can mix with some 30% juice, and I'm just going to label those X and Y. Again, no other really good variables are jumping out at me. And in order to get the liters of pure juice, we do have to multiply across, right? So I'm going to take X times 0.50 to get 0.5X. I meant to do that in purple, but it's too late now. I have Y times 0.30 to be 0.3Y. And 200 times 0.45 would give me 90. Here are my two equations. I know X plus Y is 200, and 0.5x plus 0.3y is 90. And I'm going to go ahead and solve this using elimination. It might not jump out at you, but it was kind of what jumped out at me because I know that 0.5 is half of 1. And so I'm going to multiply this row by -2 to get them to cancel out. That gives me x plus y, Bobbie, honey, is 200 minus x minus 0.6y is -180. I add these together. My x's cancel. I have 0.4y equals 20. So y is going to be 50. I know that in the end, I'm trying to get 200 liters. So I have x plus y is 200. So since y is 50, that means that x has to be, drum roll, 150. Yay! So I need 150 liters of 50% juice because we used x to represent 50% juice, and 50 liters of 30% juice. So there you have it, 3 more fully solved out mixture problems. If you have any questions, feel free to comment below the video or send me an email. If you want to hear more of my cat crying, you can watch more videos on my channel. And enjoy your evening, guys.